The final elasticity that I would like you to be familiar with is something called cross-price elasticity of demand. Cross-price elasticity of demand. This measure is going to show a relationship from buyers, or how buyers respond to changes in price, but not its own price, but changes from another price, another goods price. Okay, so this is, we'll write it like this: the percent change in price of good X, and then how do buyers respond? They're buying for another good, say, call it good Y. Okay, and here, like the other measures we've been doing, we can sort of calculate it, but here we're going to do it in a conceptual, broader way. Let's say the price of one good increases, and so its percent change would be a positive number. And that leads to people wanting to purchase more of another good, so demand of good Y increases. Okay, then we would have a case here where the cross-price elasticity is a positive number. Okay, and then it kind of uses X sub Y. If, however, the price of one good rises, and hence the percent change of good X increases, but that leads to people wanting to buy less of another good, okay, and hence its demand would decrease. A percent change decrease would be a negative number. And so it's also possible for two goods to have a negative cross-price elasticity. Here's cross-price elasticity, X comma Y. Why don't you pause the video right now and make kind of a guesstimate as to what this might mean. Okay, if you're back, note here that if a rise in price of one good leads to an increase in demand for another, positive cross-price elasticities, those goods are substitutes. Okay, and if you use an example, and it's always the case, if you use an example, it makes it more clear. But call good X like Pepsi. So if the price of Pepsi rises, we sort of expect the demand for Coca-Cola, good Y, to increase. So if the goods X and Y, Coke and Pepsi, are clearly substitutes, and we would expect positive cross-price elasticities. What's interesting here about this as a measure is that the bigger the absolute value of the number, the stronger they are as substitutes. So goods that are clearly substitutes tend to have higher cross-price elasticities. Now here, I think we kind of anticipate where this is going. But if two goods have negative cross-price elasticities, if the rise of the price of hot dogs leads to a decline in demand for ketchup, goods X and Y, those goods are complements. Okay, and so here's just maybe the scientific way to show if goods are substitutes and complements. Substitutes have positive cross-price elasticities observed in the data, and complements have negative cross-price elasticities observed in the data. The bigger the number, the stronger they are as either substitutes and complements. Of course, you could apply this measure to any two goods, and if they're neither substitutes or complements, their cross-price elasticities tend to be close to zero. And so, anyway, that will conclude our discussion here.